A couple of videos back, I put together this FPGA little dev board around one of these Lattice iCE40 FPGAs. And this was a QFP 144, so 144 pin chip. And this is en route, and I'm hoping to have this in the next week, maybe 2 weeks tops. And I can start to see if I can, get this assembled and program it and light up some LEDs or do something really basic with it, just starting really slowly. I did also order up an actual Lattice official dev board for this iCE40 that I'm going to be working with, so that I have maybe a reference or a comparison. Can I actually program it and have it do the things I'm trying to do, and then translate that into this board here, just to make sure I don't have some issue with the hardware. So I'll do some learning through that. But after that, I did, take a look at the data sheet, and I had found a higher I/O count package. And this one, was the largest I could go and still be a QFP. I wanted something that was solderable by me, whereas BGA I don't have experience with, so a lot of risk there, both in my PCB skills and my soldering skills. So I started to put together this PCB. And really, the main goal was I was coming in here and just simply trying to do the fan out of the BGA, and had some nice feedback on maybe changing the stack up on that, which I definitely will do, and other tips and tricks along the way. And there was also some discussion about what is the right way to power all of this. And I'm just using these simple linear regulators, these LDOs here, to give me my voltage for the 1.2 and the 5 volt, well, 1.2 and 3.3 volt in the scenario of this one, along with a 2.5 volt for some programming support. And really, I don't even need the 2.5 for my purposes. So it's really the 1.2 volt to run the FPGA, and then the 3.3 volt to run everything else, the SPI, the I/O, etc. Now, with that, it kind of made me wonder, is there a better way to do the power? And I went back and I looked at some of the reference designs, and I found designs that are quite simple. They use just simply these types of linear regulators, but some of them are using, if I remember right, they're using a version that has an enable pin, so that you can kind of cascade and make sure that the 1.2 gets pulled up before you turn on the 3.3. In my case, I'm not doing that, and so when I get this board in-house for this one, I'm just turning on all three of these LDOs simultaneously. And so that could come back to bite me, and we'll find out if that works or if it doesn't work and I cause some type of a problem with it. And this one here, obviously I'm just starting to experiment, so there's no board that's been ordered or anything like that. But I kind of wanted to dig deeper into the power side of things. There's just a lot of stuff I don't know, I haven't worked with before, like some of these power management ICs that could do a better job of this and maybe consolidate. This was my thought, consolidate some of these LDOs into a single package. But then I found in reality, you add so many more components to it that it really isn't consolidating. It's actually exploding the number of components I'm going to have in a board. And it kind of got me to something that looks like this. And so in this case, what I've done is I've put together a new board. It's a 100 millimeter by 100 millimeter. It is a 4-layer PCB, and I can order up 5 of these for $7 US plus a couple dollars shipping. And using some of the things I've used in previous designs, I'm using this connector here, and maybe I'll go to the 2D version for a second. This is a Molex Sabre connector, and that's just my standard way of bringing power in for these boards. And again, I chose that connector just because I had access to a large quantity of them for a very low price, and they seem like a nice, robust connector. So I'm using that. I've come in and placed in an FPGA, but this is a different FPGA. This actually ends up being an HX4K, and it's in a package that's a BG121. So it's a BGA 121 pin or ball. And there's also an HX8K with the exact same, I believe it's the same pin out, same, exact same footprint. It just internally has some additional capabilities. But these are using what's called a CA BGA, And what I'm doing on this board is using a smaller BGA than what I have over here. So this was a 256 ball BGA that is in the same form factor of a CA BGA, which I think is really about the pitch. It's a 0.8 millimeter pitch. But this one has fewer pins or fewer signals I need to route to that BGA. So I thought that might be kind of a nice practice warm-up for me before I try to tackle soldering and routing. In the routing, I think I've made it through that in something that's workable, I hope. But the soldering, I definitely have some reservations about. So maybe this one will be a little bit simpler. Still is going to have the same type of complexity to it of a BGA for me, but I think I can work my way through that with an oven, an IR oven, or hot air station, a hot plate, whatever it might be. I have those tools at my disposal. But I picked a smaller one, for a little bit easier, I would say, routing, maybe also easier on the soldering, possibly, and then also lower cost. So this other one, I'm trying to recall, maybe it's in 25 US dollars for this BGA, whereas this one here is only 10 US dollars. Or if I go with the 8K, it's 14 US dollars. So if I do manage to destroy one of these trying to do the soldering, I will have less heartburn with a $10 throwaway versus a $25 throwaway. And maybe in the process, I'll have to learn how to reball BGAs, so that might be something else fun here for me to learn. But there's other things in here, and all of this up here has to do with power. And what I ended up doing is grabbing, and I looked around for different ICs that could help me do the power, kind of give me all of my power rails from one IC. And the one that I had a bunch of different recommendations, and I did some research and also checked availability. What could I actually purchase from DigiKey or Mauser? And it seemed like this LT3504 was a pretty decent option. And so if I take a look at that for a second, let me pull that up. That would be this here. And so this is listed as a quad 1 amp switching regulator. And they talk about some of the features here and show me that I can have my 4 different outputs. So maybe in my case, I would have a 5-volt output if I want to control some 5-volt type of peripherals. 3 volt, of course, I need for the different I/O and the SPI. The 2.5 volt I'm really not going to use, but that would be for programming memory on the FPGA, the one-time programming, which I want to stay away from at this point. That doesn't make any sense for the work I'm doing. And then instead of a 1.8, I'm using a 1.2. So I adjusted these values to make sure that this is dialed into a 1.2. And this, as I'm interpreting it, is just showing that, you know, my channel 1, which in my case is going to be this 1.2 volt, is going to come on, followed by the channel 2, channel 3, up to channel 4, and that there's, you know, maybe some slight delay, but I think this would get the sequencing I need and allow me also to control. There's some option over here to control the rate at which these essentially turn on through some capacitors. So I've done something a little bit different than what you see here. But that's what I've built in this package. You know, you can see here we have a QFN type of package. So it's a 28 pin or 28 lead QFN. And if I keep scrolling down, there is a sample schematic that I've been working off of. And this is all brand new to me. So I'm trying to read up. I'm trying to leverage the sample schematic here to see if I can put this together in a way that makes sense. And like I mentioned, the adjustment I did make to this is to come in here and adjust these resistor values to get me the 1.2 volts instead of a 1.8. But other than that, really trying to get these 4 voltages out, which is great. But then there's all of these, whether it's these Schottky diodes or there's some Zener diodes, there's capacitors, there's a MOSFET up here, which I don't really have much experience with MOSFETs other than some simple fan control circuits that I built quite a while back. So on that side of it, I did go out and grab shouldn't say I went out and grabbed. I had some of these MOSFETs, which I'm going to try using. I hope this is an appropriate application of this specific MOSFET. I had picked up some old obsolete parts, basically a variety of parts at one point. Maybe it was off of eBay or something. Anyways, I had a handful of these that maybe I've been looking for something to do with them, and it seemed like this might be a fit. Could be too that these are completely inappropriate for this design, but anyways, it seems like it's an N-channel MOSFET and it's a 40 volt, so I think I'm going to try to use that. And that's what you're going to see back here, right up here. Now this specific IC here, this QFN, there was one in the Easy EDA Pro system library for the LT3504, so I leveraged that. And it has some requirements maybe for planes underneath for the power, and I've tried to work through that the best I can. And this specific MOSFET, there was nothing in the library, so I had to create that. And that was interesting because this is a full copper piece here, and only parts of it are exposed, and same with here and here. But I built that component, including bringing in the 3D aspect of it. So that when I do go to 3D, all of this stuff you can kind of see is coming through in 3D. And I did extend the footprint a little bit on this here so that I can kind of get to these legs a little bit from the outside if I need to. But then all the stuff around this is really supporting that power setup. And you're going to see here, I've got all these components that kind of go back to this graphic here, again, whether they're diodes, capacitors, or resistors, and I'm trying to get that built out. Beyond that, I did put in maybe some differences with this. I did separate each of these run lines with their own capacitor to ground. I believe the size of the capacitor lets me control the delay here, or maybe the startup, how hard or soft it is, I guess, how rapid it is. So I did break those out into some separate capacitors down here that give me a little bit more control if I feel I need it. There's a resistor here to control the speed, and this is all brand new to me, the speed at which this runs. And I did just go with this 18.2K, so that's going to means this is going to basically be running at a megahertz. And I can adjust that, of course, change that value out for something else if I want to take that speed up or down. But that's stuff I need to learn. So that's what all of this up here is. I have a couple headers to get me into my 3.3 and my 5 volt. I have this standard header I put on previous PCBs that lets me just quickly connect a little tiny LED daughter board that lets me light up eight different LEDs coming off of I/O ports on this FPGA. I have an oscillator, so that this is just a socket I plan to have, so I can put in different speed oscillators, and I'm running that into one of the global lines here. I do have a thicker trace with that, but I do run it through a VIA, so maybe at some point I can rethink some of that if that ends up being a problem. But we'll see. I think I'll be okay there. Down here I have my 128 megabit SPI flash. I've got jumper settings, whether I'm going to program the SPI flash or the one-time programming inside of the FPGA, which I'll pretty much permanently set it to all left here will tell me I'm writing to the flash. And then I have my programming header, and I'll use an external programmer versus trying to add that onto this board. And then I have these two connectors that are 68-pin connectors that should support high speed, I believe. So we'll see. I don't know how fast I'll be able to run things through these connectors, but the idea is that I would have another card either to the right or to the bottom, and I'm running the top the top and the right banks. All of those I/O pins are going to this connector, along with 5 volt, 3 volt, and grounds. And so if I go back to that schematic for a second, here's one of those connectors as an example. So I have 4 pins that are 5 volt, 4 pins that are ground. On the other end, I have 4 pins that are 3 volt, 4 pins that are ground. And then I kind of scattered grounds throughout. And then I have, in this case, the top bank and the right bank going to this connector, and then this one over here, I've got the bottom and left banks going to it. More grounds I'm sure would be nice, but this is just kind of what I could fit, so that's where I'm at with that. And I might, try to do something simple like control a little LCD screen that I could either just connect up to this little header up here, or have a separate card that gives me an LED, LCD screen, whatever it might be, an OLED screen. Maybe have some static RAM, some DRAM, maybe even get up to fancier types of RAM at some other point in the future. But I'm going to take it one small step at a time, and probably just start out with a static RAM because I understand how it works, and it should be the simplest of the options for me. But this does end up being, just this a simple 100mm squared board, 4-layer, and inexpensive for me to get this ordered up. So $10 US, and I'll have 5 of these in hand in, I don't know, 3-4 weeks. And really my main goal when I started this was just to play around with this power side of it and not even worry about the FPGA. But I thought, if I'm going to order up a little PCB just to play with this up here, it really didn't take much more to put the FPGA down, a less expensive one. If I find that the power stuff doesn't work, I won't even bother putting the FPGA on. I'll rev the board and order up something else. But if that power does seem like that is working, then I can come in and add the FPGA, and then I can add in these connectors, and then order up a paired up card to go with this that adds whatever other peripherals I want to start playing with, connecting to this FPGA. And if the 4K isn't sufficient, I can step up to the 8K in this same package. I'm just limited by the number of I/O pins versus this other one that I was working on here. Is the 8K, but has pretty much roughly double the I/O lines that I can work with. So I thought I would share that, and if anybody has any input on that, let me know. But this may be unnecessary for this. This may just simply be something I use for other future larger projects. Either way, it seems like it's a kind of a good little experiment and experience for me, just to see if I could get this LT3504 working along with the MOSFET coming into this, and see if that turns out okay. So this is one that maybe I'll look for any initial feedback. If anybody sees something that's just completely wrong here, that's not functional, and schematic wise I can jump over to this, but pretty much following, or pretty close to following, what is listed in the documentation for this 3504, along with, I added in that MOSFET up here, my own custom component for that. But if this ends up being something that I go back and I'll spend a little bit of time just double checking all of this documentation, see if I've got this laid out in a decent way, then I'll go ahead and get this ordered up, because most of these, if I'm going to do the inexpensive shipping, takes 3 weeks, if not 4 weeks, from the time I submit the order to the time I get it. And I don't want to be spending a lot of these PCBs, so a little $10 PCB set seems workable. I would say that all of this, though, the cost gets up there, so there's probably $15 US here to get all of this power stuff set up. I think this power IC, this 3504, is probably $10. These MOSFETs, I did look around at other MOSFETs too. I'm sure there's a lot of options there. These are just a few bucks, and like I said, I've got some on hand. But then by the time you add capacitors and the diodes and the inductors, everything around this, I'm going to guess, yeah, it's got to be in that 15 to 20 US for that portion of it, which is double the price of this FPGA, which is interesting. And then these connectors really aren't costing me anything. I bought a whole bunch of those at a really good price. And then the flash, I've got tons of these that really cost nothing, very inexpensive. But so maybe a PCB like this, 20, 30, maybe $40 is what if I'm doing some pretty significant rounding, that's maybe what I would have into the total bill of materials for something like this. But I'll learn through it, and whatever doesn't work, I'll use it as a learning experience and try to do something better on the next one. And it could be that on the next one I don't leverage this for all the power. Like I said, this might be unnecessary, or maybe as my designs get bigger and more complicated, it would be helpful to have this layout. And I'm sure I can improve what's here too, as far as just the layout of this and the way I've got all my copper and everything set up. But that's enough, I think, to get me going and let me experiment and see what I can do with this. As always, drop your comments below. Again, maybe just to set expectations. My focus really is the power side of this. That's what I want to get working, is this corner of it. And if I can happen to get this FPGA working after that, that's purely a bonus. And if that does work, what I learned from this board along with what I learned from this board here will probably help me go out and update this board accordingly. And this is what I'm trying to ultimately get to, is this 256 BGA with a nice power setup. So we'll see where we go on that. Good enough for now. Thanks everybody. Appreciate the continued conversation and all of the tips and tricks.